This is section 2.1. This is part 3. I want to work this problem. 9/7 r minus 3 is equal to 2/7 r. Now, I am not going to avoid fractions in this class. It is very important that we learn how to deal with them. They are legitimate numbers. They are never going away. We have to know how to deal with them. There is a method where you get to cancel out fractions before you can work the equation, but we won't be able to do that until after section 2.2. So for right now, let's just deal with the fractions as they are and treat them as regular numbers. Usually, you can cover up the fraction part and ask yourselves, well, what would I do if that were just a 9 and that were just a 2? And then whatever you would do if it were not a fraction, that's what you would normally do, even though it is a fraction. So let's look at this. Just forget that they're fractions right now. Right here, I do not have like terms because this does not have an r. I have a variable on both sides, so I need to move one of them to the other side. Since I'm going to want my constant alone as well, I'm going to choose, and it is important that you recognize that it is a choice. I choose to move this over to this side. It is workable if I move this over here. I'm going to have a lot of things to move around. We often have choices and the problem looks different depending on how you go through it, but you'll still end up with the same answer. I want to get rid of this positive 9/7 r. So I'm going to subtract 9/7 r from both sides. Now, that cancels out. And I have simply a -3 on the left-hand side now. Over here, I have like terms, so I am allowed to combine these. So I need to do 2/7 minus 9/7. Remember, when you are adding or subtracting fractions, you need a common denominator, and these already have one. So that means I get to subtract across the top, and you keep the denominator the same. Well, 2 minus 9 would be -7. And I have -7 over 7. Remember, a division is a fraction, is a division is a fraction. They are all the same thing. Fractions are just divisions that don't divide out evenly. -7 divided by 7 is -1. So this is -1r. Well, -1r is the same thing as -r. Remember, mathematicians are lazy, and if we can get away without writing something, we do. We don't write the 1, or often don't write the 1 if we don't need it. It's understood. Also remember that the property we had that said, what if you solved for and you got -x instead of positive x? What do? We change the sign on both sides. We do the same thing here. We weren't asked to find -r, we were asked to find positive r. So we change the sign on both sides, and we get that r must equal 3. Okay, now let's try some problems where we have some simplifications to do before we can continue. If I look at this problem, I have simplifications I can do over here on the left-hand side, because I have like terms here and here with the x's, and these two are both constants. I'm not allowed to combine these. This side is as good as it's going to get already, but I need to work some over here. I have 4x minus 8x. 4 minus 8 would be -4, so that's -4x. Look what we have right here. -3 plus 1. -3 plus 1 is -2. So this is -2. And I'm going to recopy the right-hand side. I would have simplified over there if I could, but I can't. So now that each side is simple, notice I did not change signs over here. I did not worry about undoing anything. I just combined. And I did that because it's on the same side of the equal sign. We only start using opposite signs when you're moving things across the equal sign, only when you start to undo things. Now that each side is simple, we're going to start to undo things. The first thing I want to do is I want to get my x's together. It does not matter whether I choose to move this one over to here or this one over to here. I get the same answer no matter what. I choose to move this one over to here. This is a minus 5x, so I'm going to add 5x to both sides. Negative 5 plus 5, that's 0. That goes away. Negative 4 plus 5 is 1, so that is 1x. And then I still have the minus 2 is equal to, that canceled out, 9. Well, 1x is just x, right? And I want x by itself, so I need to get this 2 away. So I have a second step here. I need to undo this one as well. I need to move this over to here. This is a minus 2, so I add 2 to both sides. And I get that x equals, that canceled, 9 plus 2 is 11, so 11 is my answer.